Hello friends, I welcome you in lecture number 40 on graph theory. In this lecture we are going to discuss one question on tree traversal which was asked in GTU Winter 2023 exam. We have discussed about pre-order, in-order and post-order tree traversal algorithms in previous two lectures, and we have seen that if we are given a binary tree, then how we can decide its pre-order, in-order and post-order traversal. We have discussed the ordinary method, as well as we have discussed one shortcut method for finding pre-order, in-order and post-order traversals in earlier lectures, that is lecture number 38 or 37 on graph theory. So if you have not seen those lectures, I suggest you to watch those lectures first on tree traversal and then go for this lecture. So we consider this question asked in GTU Winter 2023 exam. Question is, define a tree, that is we have to write the definition of tree, and in which order does a pre-order, in-order and post-order traversal visit the vertices of the ordered rooted tree shown in the figure. So we are given one ordered rooted tree and we have to decide its pre-order, in-order and post-order. Here they have asked the question in different way, that in which order does a pre-order, in-order and post-order traversal visit the vertices of the ordered rooted tree. So that means we have to decide the in-order, pre-order and post-order traversals for given rooted binary tree. And we are familiar with the definition of tree. A tree is a connected graph having no simple cycles. So you should write down the definition first. A connected graph with no simple cycles is called a tree. And now we decide the pre-order, in-order and post-order traversals for this ordered rooted tree. So we will apply shortcut method for finding these tree traversals. So if you recall, for shortcut method, first we consider this type of three segments for each vertex. This left side corresponds to pre-order traversal. This the line below the vertex is for in-order, and this right side line corresponds to post-order traversal. So this we mark for each and every vertex in the given rooted tree. So here also, so this is the way how we apply shortcut methods for finding these three types of tree traversals. First we mark these lines for each vertex. Here we have only one child of G, so instead of drawing this edge, we can draw this type of edge also. I can consider, if I have only one child, then I can consider it as a left child, and here I rewrite in this way, and this child was given name as K, so that I don't have problem for marking this line. Here also same thing, here only one edge is there, so we consider this H as left child of this parent D. Okay, so there is no problem if you are writing your edge in this way or in this way, both are same thing. Now what we will do, we will consider a closed curve which will pass near the vertices of this rooted tree, and whenever that closed curve will touch this line, we will write down that vertex in pre-order. Whenever closed curve touch this line, we will write corresponding vertex in order. and whenever that closed curve touches this right side line segment, we will write down the corresponding vertex in post order. So for that, before going for that, let me mention here, suppose I have to write pre-order, then in order and post order, and I start that curve from vertex A. So A is the starting point, and if we start with vertex A, then it will touch this line, and this corresponds to in order. So I will write down vertex A here for pre-order. Then we go in this direction. Here also this is for in order, so we write B. Then we write D because it is touching this line. After that, here this is for in order and vertex is H, so let me write H here. Then I have to move in this way, so this is for in order, so H is in order also, and I have to go in this way, so again I have to write H in post order also. Then I am going in this direction, so here this is for in order, this is for in order, and it is for vertex D, so I am writing vertex D in order, and then I will move in this direction. So again I have this post order line for D, so I am writing D here, and I am moving forward. So here I have vertex B, and this is corresponding to in order, so let me write B in order, and this is for in order, so pre-order, this line is for pre-order, so I am writing E in pre-order traversal, and then I am going in this direction, and for I have pre-order. Similarly, I have in order for I and post order for I, so I have to write I in order as well as in post order, and then for E I have in order, and for G I have pre-order, then in order and post order. This is J, not G. So for J, this curve is touching all these three lines for in order, pre-order and post order, so let me write J in all these three traversals, and then we are going in this direction, and for E we have post order, it touches this line, and for B we have post order, so let me write B here, and this is in order for vertex A, so I will write A here, and for C I have to write in pre-order, for F I have pre-order, in order and post order, so let me write F at 3 places. For C this is in order, then for G this line corresponds to pre-order, for K you can see it touches pre-order, in order and post order, so I have to write K at all these three positions, and then I am going in this direction, so you can see here I have to go in this way. This is in order for G and then post order for G, so I have to write G in order as well as in post order, because I have to move in this way. So first I will touch this line which is for in order, and then I will touch this line, so that is for post order, and for C I have to write in post order, this is for post order, and finally for A we have post order, and we finish our closed curve traversal. We started with vertex A, and we are ending with vertex A. So in this order, pre-order, in-order and post-order will visit the vertices of given rooted tree.